Okay, last time we looked at calculating the angle at the centre of a sector given the area of the sector. This time we're going to look at finding an angle at the centre. But this time not given the area of the sector, rather given the length of arc. Okay, so last time we looked at calculating the angle of the centre of the sector given the area of the sector and also when we were given the radius. Now we discovered at that point that that would give me a formula which I could use, which is area of a sector over pi r squared is equal to the angle at the centre, theta over 360. Now this time it's a scenario in which we've not been given the area of the sector but the length of the arc, so this bit here. Okay, so let's start with an example 1. Let's say this time there's a sector. I'm told that the length of the arc, this bit here, I'm going to abbreviate that as LOA. The length of the arc is equal to 8 centimetres. And I'm also told that the radius of the sector is 5 centimetres, and I want to find the angle at the centre, theta. Oh, remember that for area of a sector was a bit of the circle times pi r squared. And we also seen that we could generate this ratio here by bringing that down and dividing the pi r squared, so it would be area of a sector over pi r squared is equal to theta over 360. We'll remember that for length of an arc is equal to a bit of the circle times the circumference of the circle, which is pi d. Now, similar to last time, I can bring that pi d down and divide, and that will give me a ratio this time, which would be length of arc over pi d is equal to theta over 360. So the last time I generated this ratio, which was the area of a sector over pi r squared equals theta over 360. Well, the length of the arc is a bit of the circle, and it's a bit out of 360, and the bit is theta times the circumference of the circle. I can now bring that times with pi d down and divide, and that will give me length of arc over pi d equals theta over 360. Okay, now at that point, I can bring the 360 that's been divided and bring it up and multiply. So that will give me theta equals the length of the arc over pi d multiplied by 360. I can then put the information in. The length of the arc is 8 divided by pi d, well that's pi times the diameter. Well, I can see that the radius is 5, so the diameter then must be 10 multiplied by 360. I can now input this into the calculator. 8 over pi times 10 times 360, and to one decimal place that will give me 91.7 degrees. The final answer, example 2. Okay, this time I'm going to diagram this. The angle again is theta. I'm told that the radius is equal to 10 centimetres and that the length of the arc this time is equal to 25 centimetres. Okay, so I can cut straight to my ratio, which is length of arc over pi d is equal to theta over 360. And remember the target this time is to find the angle at the centre, which is theta. So that's 25 over pi times the diameter. Where's the 25 coming from? Well, that's the length of arc up top. So pi times the diameter, well, the radius is 10, the diameter will be 20, is equal to theta over 360. I'm now going to bring that 360 up and multiply. So it's been divided just now. So divide by 360, bring it up and multiply, and that will be theta equals 25 over pi times 20 multiplied by 360, and that's 143.2 degrees. Okay, let's try another. Okay, so a much bigger angle this time, which I'm going to call Q degrees. I'm told that the radius is equal to 7 and that the length of the arc this time is 40. Okay, so I can go straight to my ratio. So length of arc over pi d equals the angle over 360. Bring the divide by 360 up and multiply, and that will give me theta equals length of arc over pi d multiplied by 360. Let's start to input the information. Well, the length of the arc is 40 over pi times the diameter. Well, I can see clearly that the radius is 7, so the diameter would be 14 multiplied by 360. And to the calculator to one decimal place, that will give me 327.4 degrees. Now, one broader point to make is that when we've been given the area of the sector and we're looking for the angle, we've seen from the previous video that we can use a over pi r squared equals theta over 360. Now, when we've been given the length of the arc, and we're looking for the angle at the centre, and that's been true in the questions in this video, then we would use this one, length of arc over pi d equals theta over 360. Now we can see that both ratios have in common this theta over 360 bit. So we know that it's absolutely true that theta over 360 is equal to pi over r squared, but we can also see that it's true that it's also equal to length of arc over pi d. Now what I can do then is I can put all of those bits of information into one equation, which is that theta over 360 is equal to a over pi r squared, and it's also equal to length of arc over pi d. So at that point I just simply take the information that I need. So if I need to find the angle at the centre given the area of the sector, then it's this bit that I need. So I would select that out and use theta over 360 equals area of the sector over pi r squared. If, however, I'm given information about the length of the arc and I'm looking for an angle, then I select this bit, that theta over 360 is equal to the length of arc over pi d, and I would select that bit out and then proceed with the question.